Right, so we're going to start with types of sets. Now we touched on these topics in the table from before in the previous video, right? So a finite set. Excuse me for a second. So a finite set is any set that is possible to count all the elements, right? So any set that it is possible to count all the elements. So example would be like set A contains days of the week, right? So we'll have 7 days of the week. So there's a finite set. Set B represents numbers 1 to 10. So 1, 2, 3, comma, dot, dot, dot to 10. Right? So these will be considered a finite set. Right? An infinite set now right, is any set where you cannot count the elements, or is a never-ending set, right? So any set where it is, it doesn't look like is, I'll write it somewhere here, impossible to count or name or label all elements of the set. So an example of this would be 1, 2, 3, dot, dot, dot. This dot, dot, dot means it never ending, it ongoing, forever, or infinite set, right? Another example, if you say, like in the example given in notes, in multiples of 7, now you could keep multiplying 7 an infinite number of times. You will have 1 by 7 is 7, 2 by 7 is 14, 3 sevens are 21, 4 sevens are 28, 5 sevens are 35, and so on and so forth. So come on, you'll have 3 dots, not this line that I drew there. Let me fix that. Right, so 3 dots represent an ongoing set, right? Now, we did what a null or empty set is before. Null or empty set. Remember, these are sets that contains no elements. Right, so the example they give is a set H, where H being human beings on Earth who are older than 300 years. We don't have anybody who's older than 300 years, so that would be an empty set. So equal sets. So just like the previous video, you remember equal sets have a set, the sets are said to be equal if the elements are exactly the same. So 2 sets are equal if they both contain the same elements. So example, A is 6, 8, and 27, and B is 8, 27, and 6. even though the elements are rearranged, you can tell that they are equal, right? Because they have the exact same elements. And equivalent sets right, have the same number of elements. Right? But they don't have to be the same elements. So if A is 6, 8, and 27, and B is A, B, C, D, sorry, A, B, C, right? The number of elements in A is 3, and the number of elements in B is also 3, right? So we could say A is equivalent to B, right? So remember, this is equivalent sign, and just an equal sign means equal, right?